This week, we welcome Galen Hunt, a distinguished engineer and director at Microsoft, to talk about Azure Sphere, which is Microsoft's answer to IoT security. Our own Jason Wood will deliver the technical segment this evening on Nmap's Lua-based scripting language. In the security news this week, shutting down the internet to prevent cheating, Yubico claims a bug bounty and upsets researchers, patching MRI scanners, getting your money back after being scammed, and a couple caught selling golden tickets to heaven. All that and more on this episode of Paul's Security Weekly. This is Security Weekly, for security professionals, by security professionals. Broadcasting live from G-Unit Studios in Rhode Island, it's the show where exploits run wild, packets aren't the only things getting sniffed, and the cocktails flow steady. It's Paul's Security Weekly. Welcome. Did Larry have an introduction? Hi, everyone. This is Paul Asadorian. I guess I'm introducing...
Apparently, I no longer do. Wow, and I look short.
So, yeah, I accidentally landed in New England and stumbled my way to the G-Unit studio.
That's pretty much how I envisioned it happening, Jeff. Carlos, save the show, please.
Yes, somebody's got to do it.
Cannot be saved.
Well, it's good to have you back, Carlos. Jeff, welcome. Nice to have you in studio.
It's great to be here, Paul. Try to stay awake for the whole episode.
Yes. We've been in studio, dropping his phone incessantly. Welcome, Jack.
What? Where? Oh, hey! I'm in the studio with you guys. That's kind of cool.
In 2017, an increasing number of companies reported they did not have effective insider threat detection methods. Logarithm's UEBA solutions enable you to detect and neutralize user-based threats in real time, while built-in scenario and behavior-based analytics empower you to expose insider threats, compromised accounts, and privilege misuse. Visit logarithm.com to learn how their UEBA solutions can help you expand visibility and enhance detection capabilities. NetSparker, the developers of desktop and cloud-based web application security scanners that enable you to automatically identify vulnerabilities in your web applications and web services. NetSparker scanners employ a unique and dead-accurate vulnerability scanning engine that automatically verifies vulnerabilities with their proof of concept. For more information, visit them on the web at netsparker.com or email at contact@netsparker.com.
And welcome to the show. But first, let me introduce you to our very illustrious host. He's a man who invented a game of schmooballs and ceiling fan, Mr. Paul Asadorian.
Welcome, everyone, to Paul's Security Weekly. This is episode 565, recorded June 21st, 2018. And we're broadcasting live tonight from G-Unit Studios in Rhode Island. I'd like to No, we're going to do an interview. But first, I'm going to introduce our host this evening. To my left, Mr. Larry Pesce. Welcome, Larry.
Yeah, it's been a couple weeks.
You're teaching, I know because I was testing a new system that we're putting in place. I actually know that you're teaching SANS Security 617 Wireless and Ethical Hacking. I don't remember the title, the new title. Is that the title of the class?
Penetration Testing and Ethical Hacking.
In September at SANS Las Vegas. It's like September 8th through the 15th.
I don't know.
16th.
I got to get through August first.
Yeah. But Larry will be there teaching that.
Yep.
We're implementing a new system where I'll have this in front of me automatically.
Nice.
But
yeah, because
our first test case.
All of those are published via RSS.
Yeah. So we're working on it. On the lines via Skype, Mr. Joff Thayer is here with us. Joff, welcome.
G'day, Larry and Paul. I'm a happy individual this afternoon because, well, I achieved my domain admin at 4:30 this afternoon on my current pen tests, and so...
Wait,
yay!
When did you start that pen test, Joff?
At 4:25. Nah, I'm just kidding.
You started at like 9 a.m., didn't you?
No, actually, it's been going since about Tuesday.
Whoa.
Oh, dude, what's wrong? Are you feeling okay? Like, that's a really long time. Are people just getting better? I don't know. We'll talk about that later.
Yeah, we should talk about that. People are getting better. This is a company that was very well defended, but I still won. So, yeah.
Mr. Jason Wood is here with us on the lines via Skype. Jason gets domain admin in less than a day. So
there you go.
Well, I mean, when you hang out at the spa, I mean, you're very relaxed.
Yeah.
No pressure.
That's right. Welcome to the show, Jason.
Thank you. Good to be here.
Excuse me. Quick announcement. Come see us at Black Hat and DEF CON August 8th through the 12th. We'll have a pool cabana where you can watch us do some recording and grab some swag.
Is that what we're calling it? Recording?
Recording, partying, recording, swimming in the pool. It's all recording. We're going to record all of some of that.
Which hotel?
Both. It'll be Mandalay Bay and Caesars in each respective pool areas.
For each respective conference.
For each respective conference for Black Hat and DEF CON, we'll be in the pool area.
Very nice.
Yes, it's very nice. We had permission to film in the pool area. We had to call each hotel explicitly because it was, excuse me, outside of the conference area. So Black Hat and DEF CON were like, yeah, you need to talk to the hotel and get permission first. Otherwise, you're not going to be able to record and we have nothing to do with it. So we did actually get permission. Albeit verbal, so it'll be interesting what happens when we come down there. Because I think each one does have a topless pool, which is one thing we were worried about. Like, we're going to have cameras. Is that okay? We're going to stay in our cabana, but, you know. So
I'll make sure to bring a bikini.
Please, please, Lord, no. Please. Good Lord.
Oh, man. No, I'm not going to be there. I'd love to be there, but just show me the videos. That's all I ask.
We'll do that, Jeff. This is a very much anticipated interview, and I am very excited to bring on Galen Hunt to the show. He's part of the launch team for Microsoft Research New Experiences and Technologies organization. He founded and led the team building Azure Sphere, which was announced at RSA conference in 2018. In addition to building Azure Sphere, he manages the operating systems technology group. Previously, he led operating systems and distributed systems group as a principal researcher. Galen, welcome to the show.
Well, thank you. Glad to be here.
It's nice to have you. I want to also thank Microsoft and the public relations teams at Microsoft, specifically Chelsea in this case. I've been commenting to folks what it's like to work with large organizations in that capacity, and Microsoft has been awesome. So we're excited to have you on, and thankful that it's a joy to work with Microsoft.
And there are other organizations that have not been as nice.
Not as nice, nowhere near as nice. So and with that, we get a fantastic individual. Extremely, extremely smart and experienced. We're very happy to have Galen on the show. Galen,
someone's oversold me.
No, I've chatted with you in preparation for this interview and come to that conclusion all on my own. So, Galen, talk about how you got your start. I mean, you don't necessarily work in security, although your most recent project has security components to it. But how did you get your start in technology and operating systems?
Oh, my goodness. Oh, well, so I started programming when I was about 12. Discovered an Apple II. It was fantastic. Was able to write code. Really got into operating systems more in college and then in graduate school. So my graduate school studies were all around operating systems. And then I came to Microsoft and have been here 21 years.
So pretty much you've worked at Microsoft almost your entire career.
Yeah, most of it. Yeah, all of my postgraduate career, yeah.
That's amazing, especially in today's world where a lot of people don't stay at the same company for 21 years.
Well, I tell people it either means I've got true grit or a complete lack of imagination.
I'd vote for the first.
So I want to talk a little bit about the problems in IoT today, in the operating system and hardware implementations. And not necessarily security specific, but what are some of the problems when you were asked to look at this space? What were some of the problems that you were identifying in the space and challenges you had to overcome?
Well, let me actually kind of pull you sideways a little bit and tell you how I got started on this project.
Sure.
So I had somebody come into my office about 4 years ago and showed me the schematics for a chip that hadn't yet taped out but was under development. And it was the very first MCU I had seen with Wi-Fi built into the chip. So it had both the physical and the analog portions of Wi-Fi, an entire computer system on a chip that was going to have a price of a couple of dollars.
Wow. And now, Galen, when you say MCU, is that like a SoC or is that different?
So an MCU, think of it as the extreme version of a SoC. So an MCU literally is the entire computer on one chip. So the processor's there, the RAM is there, the storage in terms of flash is there, and all of the I/O peripherals are there on a single chip.
So someone showed you this schematic, and what was most impressive about the schematic?
Well, so the thing that was most impressive was this is the very first one I'd seen where it actually had the wireless connectivity built into the chip. Okay, and my first reaction was just this incredible excitement, because what I realized was that, you know, for a couple of bucks you could take anything that had electricity in it and turn it into an internet connected device. Okay, now then the second thing is, my second reaction after, oh, you know, anything, you take absolutely anything and make it connected, was, oh, wait a minute, this is an MCU. It's got no security. This is a nightmare waiting to happen. Okay, and one of the things I did, I went and tried to figure out how big's the market for these chips. Do you know there's 9 billion devices shipped every year that are powered exclusively by an MCU?
Like, that means like my dishwasher and stuff, right?
Your dishwasher, also every appliance in your house, your kids' toys, industrial equipment, office equipment. One of the ways I often describe to people, if you see something and it's got a status light and a button and does not have a color LCD, it's powered by an MCU. Okay. The other way for security wonks, the way to describe it is, like, kind of every motor, every fan, every blower, every chiller, every heater, every valve on the planet is controlled by an MCU, to first approximation. Okay.
Now, are these all, these aren't necessarily connected to the internet today?
No, yeah, that's the thing. So today, basically none of them are connected to the internet yet. And what I realized when I saw this schematic for this chip was that, you know, we're within years of all of them being connected.
I see. So today, an MCU on something like a heater, it prevents it from overheating and has the logic to make sure that it functions as intended.
Yeah. Well, we'll give you a very clear example. So, like, if you have a gas stove, okay, it probably actually has an MCU that's doing part of the controls on it, okay? You know, and the difference between a gas stove and a bomb is a little bit of software programming.
How true.
Some very scary threat modeling, Galen. Yes.
Okay. Yeah. Well, we go through the rest of your kitchen. You know, your dishwasher, the difference between flooding your house or not, a little bit of programming. Your fridge, the difference between you getting botulism or not, a little bit of programming.
Yeah. Certainly very, very scary. But in this scenario, Galen, what's the incentive for manufacturers to start producing all of these products for your home with this style of connectivity? I mean, certainly we've survived this long without having my dishwasher connected to the internet. Oh,
we have. Well, the compelling thing for the manufacturer, so if I'm your dishwasher manufacturer, if I can put connectivity in it and do it for basically free, then, you know, like I can let you know before something wears out on it. So instead of you coming home, I actually usually use the fridge example, you know, like with a fridge, instead of you coming home and finding out that your compressor is bad because your milk is spoiled and your ice cream is melted, you get some kind of call from the manufacturer saying, hey, you may have noticed your fridge is making a funny noise. That's because the compressor's worn out. Can we stop by and replace it tonight so you don't have any loss? Okay.
I would have loved that a couple of months ago, because that exact thing happened.
That's actually very common, yeah.
But I didn't get the call.
You didn't get the call, and I get two responses when I tell people that. The first one is either nobody's compressor everywhere is out, and the second one is, oh yeah, that just happened to me.
Right.
But and you know, or so they can give you a better SLA on that device. Another thing they could do is, you know, they could automatically ship you a new water filter when the water filter wears out instead of you seeing the light and have to figure out what to do. The dishwasher, they could send you detergent automatically, you know, at certain times. So there's all sorts of reasons that are basically around them basically getting customer insight or being able to provide a better customer experience that makes it very compelling for them to add connectivity to these devices.
So when we're faced with how do we secure these devices and these chips, certainly already we've seen several of these devices in our home, in our businesses, have, basically what I used to term as an embedded system. Now we call it an IoT device. What are some of the security challenges in your estimation? Of course, I'm referring to the paper that you wrote along with others at Microsoft, the 7 properties of highly secured devices, which I thought it hit the nail on the head.
Oh, thank you. Well, some of the immediate problems are like, one of the first things is like, do you have passwords and do you have hard-coded passwords? If you remember the Mirai botnet attack that happened back around October 16, that was all devices that had the exact same hardwired password, ROOT, right? So you guys would have been in there, in seconds. So there's things like that. There actually a really persistent problem we see with these devices is they don't have self-update mechanisms. So if somebody figures out that there's some kind of a security vulnerability in that device, the way it gets fixed in most devices today is either it doesn't get fixed at all, as in literally they never provide any kind of a fix for that, or you're supposed to remember to go look online on the website and see if you have the latest version of the firmware installed, and if not, to download it to your PC or your phone and then do an update to your device. And we know how often that's going to happen. So there's challenges there. In the devices themselves, in the chips themselves, the fundamental, what makes security really, really hard on these MCU devices is they're very, very constrained. So they don't have very much RAM, they don't have very much flash, and in most of them, in fact nearly all of them, they don't also have any internal software protection boundaries. So they don't have what we call kernel mode, user mode, they don't have process isolation. And what the effect of all that is that if a hacker can find, so let's say you did fix the password problem, maybe a few other things, but if a hacker can find one buffer overrun on that device or one misconfiguration on that device, they can get in and get execution in there, and they own the entire device, including the flash, including all the I/O peripherals, everything, and they can reflash themselves and be in that device permanently now. Mm-hmm.
Yeah, the other issues that we've been talking about for years, Galen, are the backdoor, the authentication problem. How do administrators authenticate or users authenticate to that device? Yeah. And how do we secure that? That could, backdoor passwords or accounts are one, default passwords are another. Certainly, as you pointed out, we've seen lots of things on the internet take advantage of that, lots of attackers taking advantage of that. The thing that scares me the most is, as you described, once an attacker has access, they have access to everything, which means in the case of an IoT device, I can swap out every piece of software on the device, the bootloader, the kernel, the operating system, userland, all of it,
everything,
and put that under my control while giving the user still access to the device as it functions as normal. And so, there's no antivirus software that we can put. So, how do we
anti-rootkit prevention?
Yeah. So, how do we tackle that particular problem?
Okay. You mean assuming that we've got devices like that, what do we do about it? We should be monitoring our network, right?
Yeah. Yeah. No, I agree. The only way to do that is to monitor the network.
The real answer, so the answer I want everybody to say is, we should build those devices with Azure Sphere.
Yeah, right. Because there has to be, now, I mean, sometimes there are checks against the firmware to say, hey, the firmware you're putting on my device is not so good. But the deeper of the access you have on the device, the more you could potentially circumvent that.
Yeah.
Unless something's built into the hardware, such as in a trusted computing model that says, no. You're not authorized to have, this firmware is not authorized to be on this device. That's one of the things that I really loved about Azure Sphere, is it addresses that problem specifically.
Oh yeah, we start right there because you contrast it with existing MCUs. There's no hardware protection whatsoever. Okay? So the root of the solution that we build in Azure Sphere is this thing we call the Pluton security subsystem, and it basically is a hardware rooted trust to the device. It controls the power or the boot sequence. Obviously does secure boot, but also does attestation. So it measures all the contents and signs the hashes of what you load, the device was booted with a private key that is private to the device itself, so that even software can't be able to spoof that. So that you can ask the device to give you a nonce, or you give it a nonce, and you can ask it to produce a certificate of what was actually installed on that software remotely. So you ask that device, basically, did you prove to me that you were booted with the right software?
And now, what's interesting is some of the other problems we've seen with IoT devices is the same key is used across all those devices. And I think they do that because they don't have a facility, and it's a lot of work and time and effort and money to build that facility. Yeah,
well, and it's pretty expensive to build a facility that's got the right HSMs and the key provisioning modules, right, and those pieces. And one of the ways we address this in Azure Sphere is in Pluton. It actually it generates its own key. So the way I kind of describe it is, you have a wafer of dies, and the wafer comes out of the silicon factory, or off the silicon production line, and then you cut the wafer into dies, and you put the dies into a package, and then you put the package into a test harness that validates that all the pieces are there and actually function correctly. And every Azure Sphere chip, the last thing that does in that test harness is the Pluton subsystem generates that device, that chip's individual private key. It's got a true random number generator, and it also has mitigation. It checks to make sure that there's enough entropy that, for example, you haven't put the entire silicon factory in a freezer or heated up so that you're pushing the entropy, that you're actually getting true numbers, or that you're doing electrical magnetic attacks. But anyway, it generates its own key, private key, and then it gives the corresponding public key out to the test harness, which gives it to our security service, so that we kind of and that's also when we give it the device the public key of our security service, and so that chip, now we have a trusted relationship with it, that we can mutually authenticate with it before that chip ever gets put in your dishwasher, for example. And we realized we had to do that because it was just too expensive. It's too expensive to set up the factories, particularly the device factories, to blow in keys. And you don't want to have to, how do you certify all those factories as well?
Right. As most of them are probably in China.
They're in places.
Yes. Yeah, places beyond your control.
They're in places beyond our control that sometimes ethics may be questionable.
Yeah. So now you chose Linux for this particular platform, which a lot of us found interesting because you work for Microsoft and they have an operating system that you've worked on for a really long time, and Microsoft has worked on for a really long time even before you, but you chose Linux. What went into that decision? What was the reaction from some of your peers?
All right, well, this is a really good question. Okay, so one of the things I want to make sure I'm really crisp on, we don't call it a Linux operating system. What we say is we have a custom Linux kernel. And the implication of that is it's not a full Linux distro. We have a Linux kernel, and then we have code that we put around that, both beneath it and above it. But we so the question of why did we choose to use a Linux kernel? Because it doesn't seem, obviously, 5 years ago nobody would have guessed we would have done this. Okay?
Right.
And the answer is because it is open source. Okay. Now the reason behind that, if you think about Windows, our other operating system, primary operating system, the silicon ecosystem for that platform, we only have like 2 to 3 chip vendors that produce the processors that operating system runs on. Okay, so we can have a very tight relationship with them, and we can do most of the work to support those individual chips. But in the MCU space, there are like literally dozens and dozens of MCU manufacturers, and it's because these MCUs go in lots of different verticals. There's MCUs that go into, oil drill bits that go into oil, oil drills, and there's MCUs that go in toys that go in all sorts of different places. And all these verticals, there's different companies that address these different verticals. And so, in order to produce an operating system that could run on, dozens and maybe hundreds of different MCUs, different silicon, we had to enable those MCU manufacturers to bring the operating system up on their silicon by themselves. And so by having the kernel be open source, the part that the silicon manufacturers have to interact with, they can go self-enable very, very quickly. Okay. The other reason we chose to use Linux is, well, because it is a high-level operating system. It's got security protections and processes and other things built into it instead of trying to tack it on. And so unlike in RTOS, which is what everybody else uses in the MCU space, we actually chose to use an operating system that was constructed with the idea that you needed to worry about security. Let's see. Now, the other question you ask is how did we get here? How was it perceived at Microsoft? Something like that. Yeah. Well, I will I'll answer it this way. There was a crucial conversation that happened about 3 years ago, where I was presenting the idea that ultimately became Azure Sphere, and early on in the product. With Microsoft's senior leadership team, and I was explaining what we needed to do and that we needed a high-level operating system and everything else, and that we were going to have a real hard time getting. We actually had a proof of concept. We proved that we could get the Windows kernel to run on this thing, but it wasn't. It was going to be hard from the business model perspective, not having open source, for example. And Satya Nadella looked at me and said, "Galen, wouldn't it be faster if you just used Linux?" And I
mind
said,
blown.
Okay.
It's interesting when you comment on this as little or as much as you want, Galen, and this is a pro Microsoft question and comment certainly. when Microsoft purchased GitHub, there was people who had said, "Oh, I don't trust Microsoft because." And we're like, okay, but yeah, what's the because? And they're like, oh, well, they don't like open source. And I'm like, have you paid attention to the news? Have you looked at what Microsoft has done in the past 5 years with open source and supporting Microsoft? There's options to make it run in Windows 10, Azure Sphere, host Linux. In fact, it's statistic I read, it was 48% Linux on Azure platform, I should say. Yeah. And I'm like, I think it's a whole new company, and I think they've really been very supportive of the open source community.
And I will add to that all of that because, well, I'm just going to move to GitLab, which is hosted at Azure.
Yeah. right. And so that's why I asked, because it seems to me that the culture of Microsoft has changed to be very supportive of open source.
It's changed very radically. Absolutely. And, you just... we kind of went through this transition. We realized, we might be really smart, but there's lots of other really smart people out there in the world. And if we can figure out how to work with them, we can do better things and we can create better solutions for our customers than if we try to do everything ourselves. And I think that's kind of the core thing. But, on the other hand, I can understand the skepticism that some people might have. And I guess we'll just have to earn their trust over time.
Sure. And I think Azure Sphere is one, I think, a really great way to start earning their trust. Also, there is a cloud component. So if you could talk at a high-level architecture, for example, Paul and Larry want to bring a new IoT device to market, like, what would you tell us about at a high level? How do we get started implementing Azure Sphere and incorporating in our product?
Okay, all right. So Azure Sphere is this end-to-end solution for addressing security challenges on this device, right? And our goal is to make it that any device manufacturer can very easily create a highly secured device. Okay, so there's 3 components of that solution. The first one are the Azure Sphere certified MCUs. Okay, so these are chips that have our Pluton security subsystem and a few other capabilities, requirements, so that they can run our operating system. Okay, so these chips, and they'll be provided by our silicon partners. So well, not quite today, but before the end of the year, anybody could go to, there's a company called MediaTek who's building the MT3620, which is the first Azure Sphere certified chip. Then go buy one of their chips, okay? And so you get a chip, and you put it in your dishwasher, let's call it, okay? Now, the second component of the solution is the operating system that runs on those chips. Okay, and that is our multi-layer defense in depth operating system. So, as I talked about, yes, it's got a custom Linux kernel that's been optimized for IoT scenarios and for higher security. That's actually that's the second layer of the operating system. Underneath that, there's a security monitor that protects the underlying hardware platform. It's kind of like the hypervisor that people use in the cloud for cloud implementations. Okay, but optimized for an MCU. So, and then the third layer, which is the layer above the Linux kernel, is on-chip security services for on-chip cloud services. So that's where the implementation of update over the air. It's where the implementation of certificate-based authentication. It's where the implementation of secure connectivity, basically the TLS implementation sits. And then above that, there are sandboxes where your application codes, right? Okay. So you buy one of these chips, and when you buy the chip from your chip distributor, it comes with a license to use our operating system and our security service, the third piece. I kind of got out of order, I realized that a bit. And you'll get a chip and you'll put it in your device, and then you'll download Visual Studio, because we've made it so you can use Visual Studio to program MCUs for the very first time. And you'll write your application, your control loop for your dishwasher, and your code that you might have that counts how many loads there are, for example, and contacts your cloud to let it know that maybe this customer needs some more dishwasher, whatever the thing is. And then you'll deploy that app onto the device onto the chip using the tooling that we provide. Okay. Now, and then you'll send that out to your customer. Okay. Now, when that device gets out in the field, it's going to connect to our security service, and security service is the third component. And the security service does three things for every Azure Sphere device. The first thing it's doing is it is providing all the updates to those devices for both ROS and for your application that runs on them. So it renews security through software update. The second thing that it does is it collects error reports from the devices. Okay, so one of the things we learned with Windows and Windows error reporting over the last decade and a half plus, is that quite often when hackers are trying to attack a device, they'll, particularly if they're like coming in and trying to really break in through buffer overruns or things like that, they will cause anomalous behavior on the device. And so if we actually collect information about that anomalous behavior and bring it back to and analyze it, we can often identify issues vulnerabilities before they become weaponized. Yeah. And even if we can't identify them before they're weaponized, we can analyze data that comes back after they're weaponized to figure out, how do we have to mitigate against this?
And Galen, I think someone came on the show from Microsoft to talk about that on the Windows side, how they would analyze crash reports and find zero-day exploits and vulnerabilities by analyzing the crash reports, and you've now extended that functionality into the Azure Sphere. That's
right. And what we basically, those two things, the update and the error reporting, the way I'll often describe it is, if you're building an IoT device, some device is out on the internet, and you don't have those two capabilities, you're not serious about security. You should just give up and go home.
Sure. I agree.
Okay. There are a lot of vendors that should give up and go home.
Probably, right. Because you've got to have a way to update, and you've got to have a way to get feedback. Anyway, the third thing that the security service provides is certificate-based authentication. So we do away with passwords. We do use certificates for all the authentication. So those are the three components, and what happens is your device now, it's out in the field, it connects to the Azure Sphere security service to get its certificates, to get its updates, to provide its error reports, and then you can connect it to whatever, we're back to you were building this dishwasher, right? And you're going to want to have telemetry and other things. Well, you can use whatever cloud you want, including a server running in your factory, your basement of your factory if you want, to collect that, for that telemetry to come into. We're happy to, Microsoft is happy to sell you Azure services to do that as well, but we'll also, we're not trying to lock you in. You can use whichever services you want to achieve those goals.
It's so awesome. Like, I have chills right now with hearing you describe that, because for so many years we've talked about how bad the problem is with IoT security. And even before it was IoT, it was embedded device security. And and Larry and I both, and many other members of the Security Weekly crew, I mean, Larry and I have done a significant amount of research in embedded device security, and I've never seen anything that had promise to solve the fundamental issues that we were observing every week here on the show when we talk about the news stories and did our research, until I saw Azure Sphere. And so, like, hence the chills, because though it solves those fundamental problems, like how does, and we see this in the news today all the time, ISP has put a backdoor on all of the systems, and the password's the same on all of them because they need to do some kind of maintenance or get some kind of telemetry. And that issue is squarely solved on Azure Sphere's platform. It's that administration, the authentication piece, and the updating of those devices. I mean, that's beautiful.
Well, I'm excited about it. Absolutely. Well, and so we arrived at this kind of product definition by just having lots of conversations with people trying to build these devices. And the first thing we figured out is, what is the kind of minimal bar based on Microsoft's experience building devices? So, for example, our Xbox consoles, what do those devices need to have in order to be secure?
Yeah, Galen, tell me about your discussions with the Xbox team, because you did say that you kind of relied on some of their expertise to have influence on Azure Sphere.
We absolutely have, and obviously they really don't like to talk about security. Okay, not publicly. They just feel like they don't want to draw a bullseye on their back or anything like that.
Well, and to their credit, I have not covered a whole lot of stories or talked to a lot of security researchers that are like, oh, Xbox is like really, like, I mean, even like amongst friends over beers, it's rare that someone's like, yeah, like I can totally like own an Xbox. Like, at least if anyone else on the Security Weekly team can kind of vouch for that, like Xbox serious exploits, not really talked about. Maybe
well, I will say the first Xbox had some challenges.
Sure.
Yes.
And well publicized challenges. Anyway, but they over 15 years, 3 generations of consoles, they've learned a tremendous amount about what are the basic capabilities the device needs to have in order to be highly secure. And so we kind of tracked all that, and essentially the way I'll describe it is the 7 properties are very much a capture of the learnings across Microsoft about what we have to do to build highly secure devices. And in fact, we took a lot of those learnings from Xbox when we created the Pluton security subsystem, that hardware root of trust, because the Xbox team's been building custom silicon for years, and we learned from that to go build that hardware root of trust. I think I forgot there was another question in there somewhere.
No, I mean that covers it, and that makes total sense. And you're absolutely correct. The original Xbox, there were games that had specific flaws that we would use, but they got better. Various versions of the consoles, future versions got a lot better. So now we've kind of covered the high level of like how a manufacturer implements this. We've solved Azure Sphere solves a lot of the fundamental problems that we've observed in the marketplace for IoT devices. What are you doing now to incentivize and evangelize this platform to manufacturers, right? It doesn't actually solve a problem until people start implementing it.
People actually use it. Well, I'm talking to you guys so that your friends and listeners will talk to everybody they know.
Yes, that's awesome. I encourage our listeners to do that.
So one of the things we have been engaged with OEMs, companies building devices, and a small pool of them for almost 2 years now. So we've gone out and built proof of concepts and evaluated and learned and figured out what exactly they need to tune the product to their needs. And we have we're now in private preview, which is what we've announced. So publicly announced. That's and our efforts there are trying to help educate people on this solution. The other thing I'll say is we put out that paper, the 7 properties of highly secure devices, a year ago, to really kind of help people be able to articulate and understand what were the security challenges their devices were going to have. And that paper is I've been very pleased with the number of times when I've gone in and met for the very first time with a device manufacturer to talk to them about security of their devices, and had them say, "Oh yeah, we read this paper. We hand it out to all of our engineers." Okay.
Oh, that's awesome. Yeah.
So that's good. Kind of raising that bar of what the awareness is. But anyway, we're out. So we're out right now. We're engaging with companies to start building their products that way. Later this year, we'll announce we'll bring out our public preview, which will be basically anyone will be able to get a dev kit, an Azure Sphere dev kit. In fact, people can pre-order them now to get a dev kit so that you can start prototyping and building devices. Now, the other thing, actually, so I mentioned that we have some silicon partners. Well, we really, really want the world to be more secure. In fact, sometimes I'll describe it as there's Microsoft's reason for doing Azure Sphere, and then there's Galen's reason for doing Azure Sphere. And Microsoft's reason at the end of the day, we're not a nonprofit, right? Right. So we're hoping that there will be lots of secured devices, and because they're highly secure and trustworthy, that people will feel confident buying and deploying many, many, many devices, and that some percentage of those devices will connect to other Azure services and use Azure services, and we'll monetize that. So that's ultimately what Microsoft's after. My purpose is I want to live in a secured world. I want to live in a world where these devices that are connected to all the gas and the igniters and the fans and all the other things, that those devices are all secure. And I've got a happy compromise with Microsoft. I guess right. To describe it. We've aligned our objectives, and so to that objective of trying to get every single device on the planet to be highly secured, we are the IP, the Pluton security block, for example. So the silicon IP, we're licensing that royalty free to any silicon manufacturer that will take it.
Galen, how does this impact the economics of IoT devices? And I think for certainly consumer-based devices, you've been using the dishwasher example, which I think is a valid example. Yeah. And so when I go to the store and buy a dishwasher, or maybe it's a Wi-Fi router or some other camera, price is a big factor. And it's certainly in like different verticals, when we were covering WT54G Linksys devices, it was really when consumers went to the store, they wanted the cheapest one. Like, oh, this one will work, and it's $15, $20 cheaper than the next device. I'm going to buy the cheapest one. So how does Azure Sphere play into the economics of it all to ensure that we can still keep these devices low cost?
Yeah. Well, so we add a few dollars. I'm not going to be more specific in that. We add a few, between the silicon, the enhanced capabilities of the silicon, and the security services, and running that over time, we add a couple of dollars to the bill of materials on the device. We think that if you analyze the total cost of ownership to a device manufacturer, and they start factoring in what, if they choose not to use Azure Sphere, what the security will cost, like restoring people's devices or paying for lawsuits, whatever else, start figuring just the cost. We think it's a very competitive offering, and we tried to design it that way, that it's a very competitive offering. But and like I said, we think it will add a few dollars to the price of a device, but in return, what the manufacturer gets is this confidence that they're able to build a trustworthy device, and that they can turn on new business models and new features that they would never be able to give customers otherwise.
It's interesting, and I wonder what the different manufacturers' philosophy is on it. But one school of thought is, if I implement Azure Sphere and Larry buys my dishwasher, that since I'm constantly updating it and giving him good telemetry and telling Larry when parts might fail, that Larry will have that device for a much longer time. And maybe I do that because if the dishwasher does break, when Larry goes to the store, he may choose a different manufacturer that has those nicer features, or is at a lower cost, or whatever so I can lose customers if I don't potentially have this surface, is one philosophy. Anyhow.
Yeah, it is one philosophy. And the other thing I'll say is, so in addition to the security, we also, when we talk about the value proposition for Azure Sphere, we also talk about productivity, because we've really, by bringing the full Visual Studio development experience, including the collaborative and cross-cloud and everything else to these devices, we think we've made it so that these device manufacturers are going to be able to build these devices. The time to market is going to be much shorter. The development costs, the NRE development costs will come down significantly. And the other thing is the chips. These MCUs are the most powerful MCUs that people have seen so far, and we think this is important versus other connected non-secured MCUs, because it's going to enable companies to build new customer experiences they didn't have before.
Yeah, I think that's actually a really big incentive for manufacturers to implement this platform. Galen, do you see a day where, and I think this is what you're alluding to, the scenario that I see is when I go buy a house, or when new homes are being built, or even new offices are being built, right? All of these devices are already included, like the lights, the gas hookup, the stoves, appliances, server racks, fans, the whole thing. All these devices have that connectivity, and everyone's going to be buying a smart home at some time. Do you think the future is? Do you see the future in the same way?
Oh yeah, absolutely. Yeah, and to the degree of I've even kind of anticipated, what does escrow look like on the certificates for your house, right?
Yeah, how do you? And that's interesting, because someone that I'm close with in the field purchased a home, and it had a home automation in, and the first thing that he did was unplug it, because he's like, how do I know? Right? Who still has access to my heating system, like the pool filter, the lights, the whole thing, right?
Yeah.
Yeah, that's an interesting challenge, certainly with the certificate, escrow, and how that becomes part of the process. That's really fascinating. What markets do you see adopting this technology first? For our listeners that are potentially going to go back and start evangelizing and talking about this with people they know, or maybe in the place where they work, what industries and what types of devices do you think will be the first to adopt this technology?
So our kind of analysis of the market, we expect like the appliance market to be one of the very first places, the home appliance market. And there's like, the devices are there, they're stationary, and you don't replace them that often. So when you do buy a connected one, connecting to Wi-Fi is relatively small overhead, things like that. And then there's things like HVAC and actually home security devices and lighting. We see a lot of scenarios. Those are the initial ones we see where people will flip over to connected devices. I think like the toys. Kind of like every toy being connected. I think we're a ways away from that, but sure. Isolated toys being connected definitely can. And then in factories and manufacturing facilities, and of course those facilities have kind of longer development times, so it'll be a little slower to go. And then there's kind of what I call the green. So I tend to talk about IoT as greenfield IoT and brownfield IoT. Okay, and everything that I described so far is what I call brownfield IoT. That is, there's already a device of that category. All that happens is it's being turned in. The next one you buy is a connected device, and you get some new capabilities, right? And greenfield IoT is people putting these chips into things that nobody ever thought of having even electricity in before. I'll give you a really good example. I had somebody in my office yesterday. I feel bad that I can't remember the name of the startup, but they have this ball. It's kind of like a small soccer ball that they've put an MCU inside of it, and are using it for math games. Okay. And because it's got this physics engine, so it measures. Basically you throw it in the air, and it tells your phone how far in the air you threw it. Okay, and how many times it's spun, and then they have a bunch of games that people like. And they found that in the kind of elementary and junior high, it's like really helps get the kids over a math of figuring out how to do graphing, or the math barrier of doing graphing a bunch of it. It's like, whoever thought of doing that before, right?
You could use that in your new game, Paul.
Right. I know. I was just thinking the same thing, Larry. We have a ridiculous new Office game. I'll spare you the details.
Let's just say it involves a ceiling fan.
Yes.
I think both the ceiling fan and the balls need to be connected.
That would make our game so much better. So would. It could keep track of scoring for us. It would be fantastic. Right now we're using a whiteboard. It's so archaic.
That's very archaic.
So, to the other Security Weekly members, questions for Galen?
None.
I don't have any. I think you've covered all the territory. I'm really wow. I'm just really amazed at that forward progress, and I love the fact that you guys have really taken the ball, no pun intended, and run with it on these low-cost devices. And I'm a bit of a Luddite, to be honest. I would shun them as a security professional, but I still see an interesting future there, and I love the fact that Microsoft's engaged in making this not just an ad hoc kind of world, and laying some control around it. So it's really good.
Galen, we just have 5 questions for you that are silly questions that we ask every single guest the first time they come on our show. So you're ready to play 5 questions with Security Weekly?
Okay.
The first question is 3 words to describe yourself.
Bald, nearly bald, focused, and hardworking.
If you were a serial killer, what would be your weapon of choice?
Well, IoT devices.
If you wrote a book about yourself, what would the title be?
Oh, I already know this one. The Tenacity Lattice.
Very nice. In the popular game of Ask Grabby Grabby, do you prefer to go first or second?
I have no idea. Not player, probably.
It's popular in Europe.
First.
Choose 2 celebrities to be your parents.
Alive, dead, fictional, or otherwise?
Let's see. Parents. Cary Grant and gosh, who?
The mom is always the tough one.
Yeah, the mom is the tough one.
Everyone struggles with the mom.
Oh, I don't know. Okay, so you've just shown how much.
I mean, it is 2018. It could certainly be 2 dads.
It could be 2 dads.
That's true.
That's a
There are no gender restrictions to the. There is no right or wrong answer to any of these questions. So.
In fact, if you want to pick a trans,
Madam Curie.
Madam Curie. There you go.
All right.
My 6th grade paper was on Madam Curie. There you go. Galen, thank you.
Attractive and smart.
There you go. Galen, thank you so much for appearing on Security Weekly. I love this project and the efforts put forth by yourself and Microsoft. If you were hearing us talk about the 7 properties of highly secured devices, there is a link in the show notes to that PDF. There's no registration. You can download the paper. You can go to wiki.securityweekly.com. This is episode 565. And the link is in there. You can also Google search for it, and it actually comes up on the first result. The 7 properties of highly secure devices. I encourage our listeners to read that. I thought it was a fantastic paper. Galen, thank you so much for appearing on Paul Security Weekly.
Oh, thank you so much for inviting me.
With that, thank you. With that, we will take a short break, come back. Jason Wood's going to do our technical segment on Nmap scripting using Lua and the NSE. Stay tuned.